Imagine being trapped in a body that can't express your thoughts, feelings, or desires. For millions of people worldwide, this is a harsh reality due to paralysis or other speech disorders. But what if technology could break down these barriers and restore the gift of communication? A groundbreaking study by Stanford medicine scientists has brought us one step closer to making this vision a reality. The researchers, led by Assistant Professor of Neurosurgery Frank Willett, have developed a brain-computer interface, BCI, that can detect inner speech from speech-impaired patients. This innovative technology has the potential to revolutionize the way people with paralysis communicate, enabling them to express themselves rapidly and comfortably. So, how does it work? The BCI uses tiny arrays of microelectrodes, surgically implanted in the brain's surface layer, to record neural activity patterns directly from the brain. These signals are then fed via a cable to a computer algorithm that translates them into actions such as speech or computer cursor movement. To decode the neural activity into words, the researchers use machine learning to train the computer to recognize repeatable patterns of neural activity associated with each phoneme, the tiniest units of speech. But here's where it gets really interesting. The scientists took their research a step further by investigating brain signals related to inner speech, also known as inner monologue. Inner speech is the imagination of speech in your mind, imagining the sounds of speech or the feeling of speaking, or both. The researchers wanted to know whether a BCI could work based only on neural activity evoked by imagined speech, as opposed to attempts to physically produce speech. The results were astounding. The study found that inner speech evoked clear and robust patterns of activity in the brain regions responsible for motor control. These patterns appeared to be a similar but smaller version of the activity patterns evoked by attempted speech. The researchers were able to decode these signals well enough to demonstrate a proof of principle, although still not as well as they could with attempted speech. However, this breakthrough raises important questions about the potential risks and consequences of BCIs. For instance, could a BCI accidentally decode something the user intended only to think, not to say aloud? While this might cause unintended output in current BCI systems, the researchers are proactively addressing this concern and have come up with several promising solutions. One potential solution is to train the BCI to ignore inner speech, preventing it from accidentally being picked up by the system. Another approach is to use a password protection system that prevents any inner speech from being decoded unless the user first imagines the password. Both of these methods have shown promising results in preventing unintended inner speech from leaking out. As we look to the future, the possibilities are endless. Improved hardware will enable more neurons to be recorded, increasing BCI's accuracy, reliability, and ease of use. Several companies are working on the hardware part, which is expected to become available within the next few years. The researchers are also exploring brain regions outside of the motor cortex, which might contain higher fidelity information about imagined speech. The potential impact of this technology cannot be overstated. For people with paralysis, the ability to communicate rapidly and comfortably could be life-changing. But it also raises important questions about the ethics of BCIs and the potential risks and consequences of this technology. As we move forward, it's essential to have an open and honest discussion about the implications of BCIs and how we can ensure that they are developed and used responsibly. So, what do you think? Should BCIs be developed to decode inner speech, potentially enabling higher speeds and greater comfort for people with paralysis? Or do the potential risks and consequences outweigh the benefits? Share your thoughts and join the conversation.